Hey, how's it going? In the last few lectures, we preprocessed the original discrete variables in our data, so it's time to do the same for the continuous variables. Okay, as you can probably remember, the regulator requires the probability of default model to be easy to interpret, so it must contain only dummy variables as predictor variables. Discrete variables were split into categories as they come. That is, they were fine-classed. Then we coarse-classed them by evaluating the weights of evidence for the initial categories. Now we have to do the same with the continuous variables, with just one additional prior step. We have to split them into categories. Later, we are going to treat them just like the original categories of the discrete variables. With that in mind, let's try to structure our work for the continuous variables the same way we did for the discrete ones. Suppose we have performed fine classing for a continuous variable, and we have ended up with many categorical variables that encompass the whole range of values of the continuous variable. So we'll need to calculate weight of evidence for each category and plot the weights of evidence for all categories. Previously, we performed these two tasks for the discrete variables using two functions. Why not go ahead and use the same functions here? Well, once a continuous variable is split into categories, things are certainly very similar. There's just one tiny difference in how we present information compared to the discrete variables. The categories of a discrete variable are simply different categories, and that's the only thing that sets them apart. They don't show differences in terms of quantity. In fact, they are just qualitatively different. For example, the purpose of one loan can be to finance education, while the purpose of another loan may be to buy a car. The two aren't directly comparable because they are qualitatively different. So the exact order of the categories of discrete variable doesn't matter. That's why, when we calculated our results and plotted them, we ordered the categories of discrete variables by their weight of evidence in order to group them more easily. In contrast, continuous variables show quantitative differences. One value shows there is more or less a certain property than another value. For example, an income of $100,000 is more than an income of $80,000. Consequently, when we split a continuous variable into a number of categories, these categories will also show differences in quantities. For example, a category of annual income from $80,000 to $90,000 certainly includes lower annual incomes than a category of annual income from $90,000 to $100,000. That's why we will be ordering the continuous variables by their values, not by their weight of evidence. Thus, we can easily use the code we wrote for the function to calculate weight of evidence for discrete variables and only make slight changes where needed. We can copy the code of the wo_discrete function. Let's rename the function to woe_ordered_continuous. Alright. Let's assume the function takes a variable containing the categories of a continuous variable, obtained via fine classing. If that's the case, it should perform the exact same calculations. The only difference will appear right after the function calculates weight of evidence. As we said, we don't want the categories ordered by weight of evidence. Rather, we want to preserve their natural order, which is compliant with the ascending order of the values of the continuous independent variable. Hence, we will comment out the sort_values method and the reset_index method. And that is enough. We should leave the rest of the calculations the same. Accordingly, the function returns a similar data frame with results containing weight of evidence for all initial categories from the continuous variable. As far as plotting the results is concerned, we don't really need anything else but the plot by wo function that we already have. As with the categories of the discrete variables, it is going to do the same with the categories obtained from the continuous variables that are contained in the results data frame returned by the wo_ordered continuous function. Thanks for watching, and see you in the next lecture.